Hi, welcome to chemistry. It's Mr. Duffy. Today we're going to be talking again about dimensional analysis or the factor label method, but we're going to be doing more advanced problems. So let's go ahead and get started. Dimensional analysis or the factor label method is again a way to convert units. And when we're doing that, we have to use what are called equalities. These equalities can be set up as conversion factors, again, as fractions. So that allows us to cancel out our units and make the conversion between one thing that we have measured and something that we want to convert it to. And we've talked about that in the previous lesson, but where we're going to take it today is to more advanced, involving ones that have more than one conversion factor, more than one step. So here's an example that I'm going to work through with you. We're going from tablespoons to quarts, but we don't have a way to directly go from tablespoons to quarts. This happens a lot when the units that we're converting to are kind of like far away from each other. Tablespoon is a very small unit, and a quart is a much larger unit. So normally we have to do multiple steps to get there. If we want to go from like tablespoons to cups, that conversion, might be one step, but quarts, is a little bit further away. So I don't have any numbers to this. I just want to show you how we're going to set up the factor label, the dimensional analysis, um, the fractions. So I'm going to start off with our y tablespoons. Again, no number. Abbreviation for tablespoon is capital T. And then we're going to, again, convert using fractions. What I have is we're going to need 3 steps for this, and I have the equalities listed down below on the left. 1 tablespoon is equal to 15 milliliters. 1,000 milliliters is equal to a liter, and then 1 liter is equal to 1.06 US quarts. So again, we're going to use those 3 conversions to allow us to get there. Now, technically, I don't think I'd really have to give you that there are 1,000 milliliters in 1 liter because that's a metric system conversion, and we should know how to do the metric system based on, again, other units. Well, the first fraction I'm going to set up is 1 tablespoon on the bottom and 15 milliliters, I'm going to put that on the top. Now, the reason why I do that is so that tablespoons will cancel itself out. Now, when we're done with that fraction, you'll notice that our unit that we're left in is in milliliters, and that's not where we want to be yet. We want to get to quarts. So we know we're not done with the factor label. We need to continue on. We need to use another equality. So we need to set up another fraction. We've got 1,000 milliliters is equal to 1 liter. So I'm going to put 1,000 milliliters on the bottom of my fraction and 1 liter on the top. Again, I do that so that milliliters cancels out in my units and leaves me in liters. I would still know that I'm not to where I want to get to yet because my final unit is quarts and I'm still in liters. So that tells me I have one more step to go to. 1 liter is equal to 1.06 quarts. Now, liters will cancel out in my dimensional analysis, leaving me in quarts. And now that I know that everything else is crossed off and I'm in quarts, I know that I'm done with my dimensional analysis. I would just have to solve for the amount, the number. Okay, so again, that's not something. Again, I don't have a number to actually convert yet. Let's put a number to it. So I've copied over the work from our previous slide, and now again, I just have the factor label all set up. I'm just going to put a number, 57 tablespoons, into this equation or this dimensional analysis, and now I'm going to solve it based on having 57 tablespoons. So what I would do if I'm typing in my calculator is I would do 57, and I'm going to multiply by stuff on top and divide by stuff on the bottom. So I have 57 times 15. I have divided by 1 there, but I don't really need to divide by 1 because it's going to keep the same number. Divided by 1,000 and times 1.06. That gives me 0.91 US quarts. And that's my final answer. Okay? So again, this is a problem in which case I have done multiple conversions to get to the unit I want to. It allows me again to go multiple steps, but still again converting from one unit that I measured to one unit that I don't know that I wanted to get to. Okay. take a look at another one. Still similar steps. We just have multiple steps in a dimensional analysis problem, so not much different than the last one, other than we're going from grams to ounces now. And so I'm given the problem 231 grams, and I want to go to ounces. Now, again, there might be a conversion to get directly there. These aren't too far apart. But what I have in this problem, I'm given there's 454 grams in a pound, and then there's 16 ounces in a pound. So I'm going to need to go from grams to pounds, and then from pounds to ounces. So it's just a two-step problem. The last one was again, a three-step problem. This one's a two-step. 231 grams, and I'm going to multiply that by my fraction. There's 454 grams in 1 pound. Then my grams cancels out, leaving me in pounds, but again, I'm not in the unit I want to end up in. I want to end up in ounces. There's 16 ounces in 1 pound. Pounds cancels out, leaving me in ounces, which is where I want to end up. So now I know I'm done with my factor label, and I can solve the problem. Just type it in my calculator, 231 divided by 454 times 16. That gives me 8.14 ounces. Okay, so these again are dimensional analysis problems involving more than one step. Now, we're going to take a look at one more problem, and then I'm going to leave you with a problem at the end of this video to solve yourself. And what we're doing here is we're converting from 36 miles an hour into meters per second. Now, this setup is a little bit more difficult, but still possible for us to do. What is the most important is how we set up our original given information. What 36 miles per hour means that I'm traveling 36 miles for every 1 hour. Now you notice that we start off with a fraction. We had fractions before, but they didn't have a unit in the bottom. It was just like, again, 36 miles over 1 or something like that when you convert miles to kilometers or something. Now we've got units on the top and bottom of my initial fraction, my initial given information. And so we need to still convert, but we have to convert both units. We need to convert miles to meters, and then we're going to need to convert those hours into seconds. Okay, still again doable. We just have to watch what we put where. So I'm going to start off by using what is given to me is that there's 1,600 meters in 1 mile. I'm going to start off with that information first. 1,600 meters in 1 mile. And again, notice how I set up my fraction here so that miles cancels out. So miles canceled out, leaving our top unit in meters, which is exactly where we want to be. Our top unit is in meters, and now what we've got is meters per hour. Our hours did not cancel out yet. So now we have to work on that bottom unit. So what I'm going to do is, and I don't have the conversions set up here. I would expect that you would probably know these ones. We need to get from hours into seconds. You might not know how many seconds are in an hour, but I'm sure you know that in 1 hour, there are 60 minutes. Okay, so again, if you can't do it in one step, we can definitely do it in two. Hours is going to cancel out there, goes on the bottom and the top. That leaves us in minutes. So now we're in meters per minute. Again, meters is where we want to be, but so now we need to get from meters per minute to meters per second. We would know that 60 seconds are in 1 minute, and that'll allow us to cancel out minutes on the bottom, minutes on the top. Now we are in meters per second, which is what we want to be for our final units. We're going to convert and do the math portion now. We multiply by stuff on top and divide by things on the bottom. It's 36 times 1,600 divided by 60 divided by 60. And when we do that calculation, it gives us 16 meters per second. That'll be our final answer. So it allowed us to, again, convert from a unit where we have a fraction where we have units on top and units on the bottom, and we have to cancel out again both. We just have to watch how we set up our conversion factors. So let's go ahead and take a look at one final problem. This final problem I'm going to give you to do on your own. I'll put the answer at the end of the video. And to do this problem, we're going to convert densities. So what we have is 0.0345 kilograms per centimeter cubed. We're going to convert that to ounces per inches cubed. To do that again, we need those four conversions on the bottom to be able to do this problem. And again, it's kind of set up just like the last problem where we have units on the top and units on the bottom. But what we need to watch out for here is the fact that this is, again, centimeters cubed and inches cubed. And so in this case, again, we need to remember that what centimeters cubed and inches cubed means really we're multiplying by centimeters times centimeters. And again, it's not like 3 times the centimeters, it's 3 times multiplied by itself. And that's the same with inches cubed times inches cubed times inches cubed. And that, again, when we're doing our conversion, it makes it a little bit trickier, but we're going to have to do the conversion 3 times because cubed means 3 times. It's something, again, to kind of watch out for when you're doing this problem. But again, I'll show you my work and I'll show you the answer at the end of this video. I want you to just try it on your own. So hopefully this video makes a little bit more sense how to do conversions involving more than one step and conversions where we have something on the top of the fraction and something on the bottom of the fraction, units on the top and the bottom. Thank you for watching.